Here we go, peeps. Let's pick out some pinks if we have some. Eliminate the parameter and write as a single Cartesian equation. That is an equation in only x and y. So what we're trying to do is get rid of the t. These are parametric equations. T is the parameter. Eliminate the parameter. Get rid of t. Right? Who has an idea about how we could do that? Get rid of the t. What? Get t by itself. All right, that's one option. So, Jay, guess if I'm going to do that, I'm going to do it with the bottom equation. That's going to be easier. So y plus 3 is t. Then I can take this guy right here and plug him in right here. Would you agree with that? So x equals 2 plus 4 times y plus 3. You see what we just did? Now, I'm not done yet, but you see what we just did?
Yeah. There needs to be another, or wait. Never mind. I thought I was done.
Okay. So x equals 2 plus 4y plus 12. And I'd probably write that x minus 4y equals 14.
Well,
Because then
How'd
it
you get
looks,
minus 4? Oh, you swap sides.
yeah. So it's a line. And instead of having x equals, I'm going to
Is
have
that
x
it?
and y together.
Is that it?
And that's it. That's the answer. What was your job? Stop. Read the directions. What do they want you to do? Write an equation that has just x and y. Is that what I did? Yeah. Now, I want to show you something else. This won't always work, but in this problem, it would be fine. I turned this equation around so that my t's were lined up. What if I multiply this bottom equation by -4? The top equation will stay the same, but the bottom equation would be this. Would you agree with that? And now what happens when I add those together? I get x minus 4y, but don't add, you can't combine them, they're not like terms, equal to 14, and what happened to my t's? They were eliminated. I used elimination. This is called substitution. You solve for t and substituted it in. It's fine. It'll work every time. I could also have used elimination in this problem because my goal was to get rid of the t's. Just get rid of the t's. Do whatever you need to do to make that happen.
If you have to make like a graph, what will the instructions say? Or like, isn't there like part of this problem where you like make a graph or something?
In the notes and the homework, yeah. So it said, so here are your parametric equations, and then it gave you some t values, like t is 0, t is 1, t is 2. So you plug those in, and if you let t be 0, for example, you would get 2 comma -3, and then you could plot that point, 2 -3. So it would say, here are some t values, find the points, and then sketch. And it would say that, it would guide you through it, because this was like only one step of that multi-step problem. All right, we good on that? All right, number 2. Is the inverse of the log function a function? Okay, wait. The inverse of the log function. Okay, stop right there. What does the log function look like? ln x, BFF, what's ln x look like?
Oh.
here.
It's sort of long.
It goes up. Yeah.
That's what it looks like. Now, that is called, that's one of your basic functions. That, right there, that is a function because why? It passes the
Vertical line test.
vertical line test. Right? What do we say about inverses? They have to pass the horizontal line test, right? Does this thing pass the horizontal line test? Okay, now I want you to think about what that means, you guys. Okay, here's one that doesn't pass the horizontal line test. And it doesn't because this might be the point -2,3, and this is the point 2,3. So you have repeated y's. Are there any repeated y's here? No. So when I do the inverse and I switch my x's and y's, if there's no repeated y's, there won't be any repeated x's. So we're good. The inverse is a function. If you want to know if the inverse is a function, use the horizontal line test. Jake?
Oh, what does the inverse of this look like? Like, would it
Well,
just be
it
like?
would take all the ordered pairs and flip them. And it would take, what was x equals 0 is now gonna be y equals 0, because remember we switched the variables. That would become 1, 0, or I mean 0, 1,
Oh, and then it would just be like.
and then it looks like that, yeah. So the inverse of the logarithm is the exponential. You don't need to know that to do this problem. What do you need to know to do this problem? Does it pass the horizontal line test? Okay? Now, I need everybody really zeroing in, okay? If the question is that picture a function? You use the vertical line test. If the question is the inverse a function? You use the horizontal line test. Okay? We're looking for information about the inverse. We use the horizontal line test. All right? Find f of x, or find f inverse. So now we're going to find an inverse. Okay. Do you remember the steps? Well, I did the first one for you. When I wrote my problem down, I changed the f of x into y. Right? Because f of x is the same as y. Right?
Yes.
Okay, thank you. All right, now what do I do?
Plug in negative y. Oh, wait, no,
Now I switch my x's and y's. So x equals 2y plus 1 over 3y minus 2. Now what? Ultimately, I'm going to solve for y, but that's going to be harder than. I mean,
then you
there's a
times
little
it
more
by
to
3.
it.
You times it by 3y minus
So
2.
this has to
Or
come
plus
over
2.
here.
Yeah.
No. This comes over here. So I'm going to have 3yx minus 2x. I bring this over here. So 3yx minus 2x. Bring this over here. So it's not here anymore. It's over here now. Distribute. Now what? If the y's on the same side, Keller Brown, you're awesome. So 3yx minus 2y and 2x plus 1. So I'm going to add the 2x over, because he doesn't have a y, and I'm gonna subtract the 2y, because he does have a y. Now, they're both on the same side, so what can I do with them?
Divide by x.
Factor out a y. Because if I factor out a y, then I only have one y now. And as somebody said earlier, my job is to solve for y. Now I have just one. So I'll divide. And that's my inverse. So my inverse is 2x plus 1 over 3x minus 2.
That's the same as you.
Wow. That means it's its own inverse. Yeah, that doesn't always happen. Please don't think that always happens. But it's its own inverse. And there are lots of functions that are their own inverses, and this just happens to be one of them. If I tried to make that happen, I wouldn't be able to do it. But, yeah. Those are the steps we go through, and whatever comes out is what comes out. All right, you ready? All right, number 4. So I've got this generic shape here. Got that little semicircle. And it's got this triangle. And then it's got another semicircle. So this is my function f. So this is my original function. A says, okay, now graph this. All right, so let's talk about how my picture is going to change. What does that negative in that location do to my picture? What's going to happen to it? It's going to flip it sideways. Where is the negative if it's going to go upside down? Out here. The negative out in front is upside down. A negative inside changes the sign on X, which moves you to positive, negative, negative to positive, sideways. So this is going to be a sideways flip. Now, I'm just going to go ahead and do that right off the bat. So what does that mean? That means that this stuff that's on the left is now going to be on the right. So I'm going to have this little semicircle over here on the right. There it is. That guy right there. And then this stuff is coming to the left. So I'm going to have my triangle and my downward semicircle. I'm not finished with the problem, but that is the sideways flip part of it. Would everybody agree to that? All right, what else has to be done? What is the other thing that has to be done? Up one. So I'm just gonna go ahead, I'll use my colored pencil or use my eraser to erase it or whatever, and I'm gonna go ahead and just lift this up one. So here's one, up one. And I'm gonna lift everything up one. So this is coming up here. This is coming up here. There's my semicircle now. My triangle is gonna come up one. So it's gonna look like this. And that semicircle is gonna look like that. So I'm gonna use my eraser. There was my original flip. Lift it up one. Now, some of you can do all that in one step. You don't have to do it in stages like I did. That's great. If you do it in stages, just make sure I know what your final version is. Okay, we good? All right, the second one, again, we're using that very same original picture, but we are going to do something to it. What is happening this time?
Go left.
Left two. You are going to take that picture right there, and you're going to pick up every single point and move it left two. So this one is already left two. Now it's going to go left two more. And I'm going to draw my circle. So basically, when I do it, I move each little piece. You can do point by point, whatever works for you. So negative 2, 0 became negative 4, 0. Negative 1, 1 became negative 3, 1. Every x got moved over 2. Are you okay with that? And then the last one is 2f of x. All right, tell me what happens here. Multiply the y or the vertical, the height, by 2. So what does that mean? This is my original. See that circle right there? He is up 1. Well, now he's going to be up 2. He's double. Double.
Is it just,
Doubles your height.
Just the height.
Just the height. That doubles the height. So I'm going to go up 2 to make my circle. Now it's like an oval now. Now, what about my triangle? How tall was he originally? 2? Now he's going to be 4. So instead of going right 1 up 2, I'm going right 1 up 4 to make that triangle. Jake? What?
Is this only on the positive side of the graph? Like,
No, we double every height. So that's going to go down to negative 2. Or negative 2. So it's exactly the same picture. Everything's in exactly the same spots. It's just stretched. Now, I'm going to throw in So what changes did we make? We moved left or right?
Left.
Well, yeah, this goes left, but right would be the same thing, it would just be x minus two. So we practiced that. This one, we multiplied the height, so we practiced that. In the first one we did, we flipped sideways and moved up and down. So what have we not practiced in there? I'm gonna keep this shape. We didn't practice absolute value, so let's practice that. We didn't practice changing the width. Practice that. Okay. Alright, let's practice these three. If you need more graph paper, there's some right up here in front of Charlie. Alright, who remembers? We just talked about this yesterday or the day before. Who remembers how to take the absolute value of the whole picture?
You flip it upside down.
You don't flip it upside down.
Make
You
the right
bring
side.
bottoms up. So only the bottom changes. So this circle here is going to stay the same. The triangle is going to stay the same. But the negative part of the picture becomes positive. So only the bottom comes up. So it would look like that. This is bottoms up. Anything up here stays exactly, you don't change a thing. But this part comes up.
Nothing in the mix.
Now what, this looks different, right? That looks different, you gotta see that. What does this guy do? How do we handle that?
Only it makes the right side.
We right, so we draw the right side. So the right side is going to be my triangle and my downward semicircle. Okay, so there's the right side of the picture. Don't change a thing, draw the right side of the picture. Then what? Mirror it onto the left. So in other words, draw your triangle over here and draw your downward semicircle over here. So when you have the absolute value of x, draw the right side of the picture and then redraw it on the other side. Alright, and what about this guy? What does this number do? Now, stop. A number out in front multiplies the height. We did one of those. What does a number, a coefficient inside do? Divides the width. Okay, so let's look at our original picture. How wide is that little semicircle? 2. Divided by 2, now it's going to be 1. So you've got the same semicircle, but it has to happen in just one space now. How how wide's the triangle? 2? Well, now it's only gonna be 1. So you've got the exact same triangle, but now it's happening in only 1 space instead of 2.
So whatever's inside just becomes the opposite. So because that's multiplying, that just becomes dividing.
Yeah, always. Whatever that number is, it's division. You're dividing by it. So if that number, if you had this, you would be dividing by 1/2, which is the same as timesing by 2. This number is a divider. All right, and finally my bottom semicircle is 2 originally, so he also is going to be just 1. Now, your picture that you're given on your quiz won't be this picture. I just made this picture up. I'll just make up another one. But all the transformations we just practiced, you'll just do what you just did, but it won't be that shape. It will be something else. Okay? And we've practiced them all now. I think we have all the transformations. Okay? All right, so tomorrow we'll have a little quiz. It will be, now listen, boys and girls, have I ever given you an assessment that we didn't practice for? No, 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 no. Some of you don't do very well, but that's because you don't practice. So what's on the quiz? What do you need to know for the quiz tomorrow? You need to know these things, right? Plus the extra transformations that I put up there.
Are we gonna need to know like all the BFFs since this one asked it out?
You are going to need to know the BFFs in order to answer questions like Grace, we're already supposed to know the BFFs. Right? Never forget your BFFs. Now, I wouldn't spend 15 hours studying those. I would be making sure I know how to graph my transformations. But yeah, you could have a question just like that tomorrow. Might be the quadratic. What if I said, is the inverse of the quadratic function a function? You would say no. Because what does the quadratic function look like? A parabola. And it doesn't pass the horizontal line test.
Without the exit of the inverse.
Yes, if it said, well, it would never say this because our BFFs are functions, but if it said, is the quadratic function a function, you would do vertical line tests. Okay, let's get our notes out then, my friends. No. All right. All right. Here we go, 1.7. Did we already make a box?
Yes.
What do you?
We can do it again.
No, we're gonna do it again. Well, I know we did some box things, I just couldn't remember if we actually made a box or not. So you understand the basics of what's happening in 1.7, number 1. You've got a piece of paper that's 12 by 15. You're gonna cut out square corners. Don't know how big they are, but we learned when we made our boxes that if he and I have different size corners, our box is going to be different, right? The flaps are folded up to make an open top box, so here are the creases. Folded up to make an open top box. And job is to build the biggest box possible. Okay. Need an equation for the volume of the box. Anybody remember? We did this.
Length times width.
Well, it's gonna be length times width times height, absolutely. But what will the length of the box be in this particular problem, Tyler?
2x. 7 15 times. Oh wait, no, it's 7.5.
Okay, what was the length of the original piece of paper? 15. And what did we do? We cut off X on this corner and X on this corner. So what's left? What is this now? The whole thing was 15. What's this length now?
15 minus 2.
No, 15 minus
4x.
2x.
an X here and an X here, right? So 15 minus 2x. Now what about the width of the box? 12 minus 2x. And then remember, we're folding up the flaps, so what's the height of the box? X. So there is your formula, or equation, for the volume. Now, beady little eyes, looking up here. If I change the dimensions of the paper to 20 by 25, 20 minus 2x, 25 minus 2x times x. That is the equation for the volume, no matter what. You just stick in whatever numbers you got. Now we're going to go to our calculators in a minute, but before we do, we have to answer the question of domain, which we have already talked about. Domain is x's. So when I look at this equation, or look at my piece of paper, what can x be? Can x be everything? Like all reals, negative infinity to infinity? No, because x can't be negative 5. But x also can't be 500. Right? So what can x be? 0 to 15. I hear 0 to 15. That would be like this. And he's saying it's between 0 and 15. Let's talk about that. Can x be 12? 12 is a number in there, right? Can x be 12? Absolutely not. Because the paper is only 12 across. Can I rip a 12 and a 12, these two pieces right here, can I rip those off if I only have 12 to start with? No.
Could be
Joe?
6.
Joe says 6. Let's change that 15 to 6. Now, can x be 5? I'm picking a number between 0 and 6. Could x be 5?
Yeah.
Because if you had 12 and you took 5 off each side, that would still leave you with 2. It would be a skinny little box, but you'd still have 2. How about if you took off 5 here and 5 here? You'd be okay, because you have 15, right? Can he take off more than 6? Could he take off 7? No, because he doesn't have enough room up here, right? So where did this number come from? It's half of the smallest dimension. That's as big as you can get. think about that. Does that make sense? I know you're gonna memorize it, okay, fine, but does it make sense? You can't be bigger than half the smallest number, because you wouldn't have enough to rip off both sides. This is your domain. That's your domain. Bless you. Bless you. All right, let's go to the calculator. And let's find the maximum volume. So we go to y equals, and we type in our equation. We talked about this before. You do not have to multiply it out. Just type it in, just like you wrote it there, with the parentheses and everything. Go to window, X min, X max. Now, what are you gonna put in for Y min and Y max?
20.
Well, Y min is gonna be 0, because Y represents the volume. Can I be less than 0? So that's gonna be my box. So Y min is gonna be 0. Now, you wanna use 20 for Y max?
No.
No?
That doesn't work.
Dang.
50?
50? Let's try 50. And hit graph.
Okay, so no.
Usually go up.
Now, there's nothing wrong with 50 except I'm looking for the maximum, right? And when I use 50, my picture looked like that. Is that what yours look like?
Yeah.
Okay, so that tells us, whoops, we need to go high.
200.
200.
200 looks good.
200 looks good. 200 looks beautiful. So with 200, I see that. This is the point I'm looking for. So second calc max, left bound, right bound, maximum. I got 2.209, comma, 177.234.
I got it. Is it never infinity?
Every time you find a maximum or minimum on your calculator, it's going to give you a point. You're going to get an X value and a Y value. So now we have to decide which one of those two numbers answers my question. Well, what was my question? Find the maximum volume, which when we set it up, volume was Y? So the answer to the question is 177.234 cubic inches. What did this number stand for? Well, that number is X, right? What did X stand for in my problem?
Those little squares.
The size of the corners that you cut out. So if you want to build the biggest box possible, you're going to get your ruler out and you're going to cut out corners that are that big. Okay? All right, number 2, with your partner, repeat number 2, or repeat number 1. Only thing different is your paper's 21 by 16. Domain, max volume, size of corners, find it all.
Oh, because that's an X.
I got 3,450. Anybody else get that? I actually got 2.999999. So 3,450. Get it? Okay, all right. So what are the answers to the question? What was your domain?
0 to 8.
0 to 8. And when you go to draw that on your calculator, that is your X, min, and max. That's it. If you don't make that adjustment, you'll see more of the curve, and you might find a different point, another maximum point, and that will be wrong because you're only supposed to be looking at 0 to 8. Okay? And then I had to adjust my Y because it went way higher this time. So I got 450 for my max. What is that 450? The maximum volume is 450 cubic inches. And how big are the squares? 3 inches. Got it? Easy. All right, switching gears. A jumper that normally costs $11.50 is on sale for 30% off. This section is all different kinds of word problems, in case you haven't noticed. We're just gonna do word problems for a couple days. So a jumper that normally costs $11.50, here it is on sale for 30% off, so I have to subtract 30%. And then I'm going to add 7%. All right? Now, I'm not sure how you have done these in the past, but I want you to think about this for a second. If it is on sale for 30% off, if I multiply 1150 times 30%, 0.3, what is that going to tell me? How much I don't have to pay? Okay, I don't care about that. I want to know how much I do have to pay. So I'm not going to multiply by 0.3, I'm going to multiply by 0.7.
What would you?
Because if I'm not paying 30%, then I am paying 70%. Would you agree? Absolutely you can. But I want you to think about something, Tyler, because I'm going to turn around and put tax on that. So now you're going to multiply by 0.3, subtract, then you're going to multiply by 0.07 and add. You got a 4-step problem, I'm doing it in 1. There's no round off error, because I'm counting off for round off error.
Oh.
There's no round off error. What do I multiply by if I am adding on 7%? Not 0.07.
0.3.
1.07. That's what I'm multiplying by.
Wait, what?
All right, now just stop. The sweater, the jumper is 100%. Right? The original cost of the jumper is 100%. What did I do here? I took 100% minus 30, because I'm taking 30 away. But tax is not a takeaway, tax is an add-on. So I'm gonna take 100 and add it on. And I'm gonna do that multiplication, I'm gonna have my answer. Now, in these kinds of problems, guys, you never multiply by the percent that's in the problem. So don't multiply by 30, you multiply by 1 minus 30. Don't multiply by 7, you multiply by 1 plus 7. Because I'm interested in what I'm paying. Not what they're adding on, not what they're taking off, I'm interested in what I'm paying. And then type it in on your calculator, and that's your answer. Did you get, oh wow, this is a good deal. Did you get 861?
Yep.
Okay, 861 for that jump. All right, here we go. Now we're gonna do the same thing. We're gonna buy a shirt. It's $16.95. So start with $16.95. You've got a discount of 18%, and you have a tax of 5.5%. So what am I gonna multiply by? This number is going to be 0.82, because this number is 1 minus 18%, or 100 minus 18. And what's this one gonna be? This is an
1.055.
add-on. So 1 plus
0.5.
0.55. Remember, you're not gonna multiply by 18, you're not gonna multiply by 5.5. You're gonna multiply by 1 minus 18 and 1 plus 5.5. And that shirt is going to cost you how much? $14.66.
Okay. Not too shabby.
All right, quick comment. Let's suppose all of a sudden the principal shows up at the door and she says, Lisa, you've been doing a great job. We're gonna give you an 8% raise. I would dance around, be all happy. How would I figure my salary? If she's gonna give me an 8% raise, I would take whatever I'm making right now and multiply it by what? 1.08, right? Because I'm adding on 8%, right? What if she walks in and says, no, you're not doing a very good job, we're gonna take away, we're gonna cut your pay 8%. What would I multiply by if she's gonna cut my pay 8%? 192. Okay, so I never multiply by 8%. It's 1 plus 8 if I'm getting a raise, and it's 1 minus 8 if I'm getting in trouble. Right? Okay, let's stop there. That's enough for today. And we can, after our quiz tomorrow, we'll pick up there. Okay,